All right, what you need is, and this is why I had it published, is you need this, it's called a Desmos calculator. So click on that link and then open that up, or it should just open up. This is the calculator that you will have available when you take the state test. And basically everything that's on there you can do without it, but if you know how to use it, you can honestly make some of these problems a lot easier than normal. So that's what we want to just go over, is how to use this. And it is a graphing calculator. Now like here, you've seen me use this, and maybe you have brothers or sisters that had this at some point. This is a graphing calculator, but this is the one that will be available to you. And if you got down here, so you have like this menu here, you see where that keyboard is. So I can type in number 1, I can type in y equals x, and it's going to graph that line. It's going to show it to you. It's going to graph that line. So we basically graph anything and use this kind of, figure some things out. Now, if I just hit the X, it goes away. There's some different things here as well that we may look at. And let me see where so let me do this. All right, now what does it say to do up there? It says solving quadratic equations by what? By graphing. All right, so by graphing. So we're going to use the Desmos calculator to do the hard part. We've graphed before by plotting points and finding other things, but now we're going to use the Desmos to do the hard part. Okay, for that. So now, let's see here. One way to solve a quadratic equation in standard form is to graph the related function and find the x values where y equals 0. In other words, find the zeros of the related function. Recall that a quadratic function may have 1, 2, or no zeros. All right, so what you want to do, whoops, I don't want that, is in order to do this, we want to set this equal to 0, which it is. And now what you want to think about this is y equals 2x squared minus 18. So underneath that one, just write y equals 2x squared minus 18. Now, once you have that, go to your Desmos on your computer, and here on 1. Now, you can either use the keyboard or you can use this. I mean, if you hit Y on the keyboard, that's fine. It'll still work. If you hit the numbers on the keyboard, it will still work. So if I do y equals 2x, now it'll start graphing. Don't worry about that. Now, I need this squared. See where it says a squared? If I just click that, it'll make it squared. And then what was it, minus 18? Minus 18. Now, if you want to see more, let's see, can I pinch this? Like if you need to see it all, it'll change that a little bit. So you can zoom in or zoom out, depending on what you need for this, and then you can move it over. Well, what are we looking for? It says solve each equation by graphing. What are we looking for? Where are the answers at? Okay, that's kind of the hard thing. Okay, where are those answers at? Man, any ideas? What we're looking for?
No.
Okay, y equals, and you're gonna use the equals sign. Yep. 2. So we're doing right here. The first one. Yeah. Still confused. Yeah, we're doing this first one. And you need to write it like that. And that's 2x, and then to get squared, how do I do this? Go to that keyboard, and then you hit that right there. Yep. And minus 18. All right. Preston, you got an enter?
Yep.
Allie, you got an enter?
Mm-hmm.
Let me see something here with my keyboard here. I want to do 2x squared. All right. if you're using the keyboard, the caret key, look at number 6. What's above 6 on your keyboard? What symbol above it? Little
Upside down.
upside down V is called a caret key. That's another way to do squared. So if I got X and I hit shift and 6, it'll pop up there, and then I just hit squared, and then I hit my right arrow key. There's different ways to do it. You can use the keyboard of that. All right, Zach, do you know the answers? No? All right. Here's what you're looking for. This is the graph. And when I say, do you know the answers, we're talking about this. It says solve each equation. Where does that equal 0 at? What X value, when you plug it in, makes the graph equal 0?
3 and -3.
It says 3 and -3. Because what are we looking for? We're looking for right there where it hits the x-axis. So what I would like you to do is on your paper, just give me, it doesn't have to be super accurate, but I want enough to know where does it hit the x-axis at, and just give me a rough sketch of what the parabola looks like. So just do that right underneath that problem, if you would. Now we got to answer it, and he just said x equals -3 and 3. Those are our two answers. That's where, this is what we're looking for. This is what we're looking for. So if you know, if it gives you a quadratic, you can just graph it and say, boom, where does it hit 0 at? Now, a couple things you got to be careful about. Take a look at that second one. Zane, you with us? We're here on the.
Yeah, I got it.
Okay. Now, there is an issue here. What do we want it to equal? We want it to equal 0. So if you just type this in, you can't type this in as it is. You got to hit, you got to subtract 8, and you get x squared plus 2x minus 8 equals 0. Once you get that, underneath it, rewrite y equals x squared plus 2x minus 8. So write that. And graph it. Once you have it set equal to 0, we're looking for where it equals 0. So, and I want to make sure you're able to manipulate that, the calculator. And then you can do it under y2, and you'll have both equations show up, or you can erase the one under y1. Doesn't really matter. Yeah. And where's your graph at? Yeah. So, all right, Colin, can you see it?
Yep.
So you got it? All right, Sam, can you see it? Rachel? All right. So what was it? Y equals x squared plus. So I'm gonna go back here and let's see. How do I go back? Delete. Hey, where'd it go? All right, and so I'm just gonna hit X, and I can do it right from here. X squared. What was it? Plus 2x. Plus 2x. And then what else? What's going on here? Why does it keep doing that? Plus 2x minus 8. Now you can, if you notice, it graphs it like each little piece as you do that, and then it changes it. So if you look, so like x squared plus 2x, that's that graph right there. And so it's not the final graph until you finish and you put in the minus 8. Well, we're looking for the zeros. So go to your 0. Where's it hit at? It hits at -4, and where else? 2. It's at -4 and 2. And so if I graph this, okay, I'm just going to graph it beside here. It hits at 1, 2, 3, 4, 1, 2, dot there, dot there. The answers are x equals -4 and 2. Now, if you were given this equation on the test yesterday, okay, if you were given that equation on the test yesterday, how would you solve it? Pay attention, George. Okay. Well, just to kind of fix a couple of mistakes. Preston, what would you do?
You have to find what multiplies to negative 8, that's 2.
And what are those?
4 negative 2.
Okay, and we would factor it into x plus 4 times x minus 2 equals 0, right? And then we would say x plus 4 equals 0, and we would say x minus 2 equals 0. And then you would subtract 4, and you get x equals negative 4, and we add 2, and you get x equals 2, right? You got the same answers, correct? So if we can use this Desmos, okay, if I can use this Desmos to graph it, it's going to be a little bit easier. And you can. You just got to understand it. Okay, that's the key thing. You just got to understand it. All right, do those next two on your sheet, knowing that what do you have to do? You have to set them both equal to what? Both equal to 0. And for C, it really doesn't matter which way you move it. If you don't get a whole number where it hits, round it to the nearest decimal, because you can get that. It doesn't always, it doesn't always hit a nice whole number. That's why graphing is a little bit nice. It'll help us out. Well, actually, let's just go through this first one and see where you're at, or if you're stuck, whatever. Now, there's two options. Some of you, did anybody move the x squared over and make it minus x squared? Okay, absolutely fine. Then you got y equals negative x squared plus 3x minus 5. Okay, here, grab this. And then go to Canvas and then help them out, Preston, if he has questions. Okay. And then did anybody move the other two over, keep the x squared positive? No. All right, I'll just show you the difference so that you would have y equals x squared minus 3x plus 5. All right, so we go to Desmos. Let me see if I can do this. And all right, so now here, what do I got? I got x squared, negative x squared. So I'm gonna put a negative in front of there. Do we have a plus or minus? And then what do I have? Plus 3x. And then I got minus 5, right? And so I go back and I got minus 5. Is that what yours looks like? Okay, what does that tell us? We are looking for the solutions to that equation. Does it hit the x-axis? No. So what's our answer? No solutions. Okay, and technically this is where we say no real solutions because it doesn't hit. If I type in the other one, if I type in this one, if anybody did it the other way, y equals x squared minus 3x plus 5. Okay, it just opens up, but it does, again, it doesn't hit the x-axis. So either way you do it, you get no solution. So here I get no real solutions. Doesn't hit. All right, now for D, I need to move the 6x over. And so I get subtract 6x, and I get y equals 3x squared minus 6x plus 3. Put the 6x, it's helpful to go in that order. And now go ahead and, well, it should be equals 0. I jumped the gun here a little bit. Hold on here. That should have been the next step. So it should be 3x squared minus 6x plus 3 equals 0. And once we get it like that, we're just going to graph it as 3x squared minus 6x plus 3. So I'm going to go over here. I'm going to get rid of that second one. And let's see here. Go back one. 3x squared minus 6x. I'll just do that. And then what do I have? Plus 3? Plus 3. 3x squared minus 6x plus 3. Okay. Does it hit the x-axis? Yeah, it does. And what is that point? Now, if you go to that point with your cursor and you're interested in what point it is, it will tell you. Okay. So that means our answer is x equals 1. Okay, we only get one answer, and that's okay. You don't have to have two answers every time. So you get x equals 1 for that. All right, we're going to keep using the graph. It says a rocket is shot straight up from the ground. The quadratic function f of t equals negative 16t squared plus 96t models the rocket's height above the ground after t seconds. How long does it take the rocket to return to the ground? What's the rocket's maximum height? All right, go ahead and graph it. Now here's the thing, you got to make sure you can see it on your screen. So go to there, now yesterday you either would have factored or you would use the axis of symmetry to figure this out, which I think is what Colin did. And that's fine, because everything you can do without graphing, but graphing can make some things easier. All right, so plug that in as it is. See it? Yeah. Without, making it that skinny. Try to see. So what do we got here? Negative 16, and just make it x squared. And so negative x, or negative 16, hold on. Wait a minute, what am I keeping? 16 x squared plus 96 x. Okay, let me do this full screen now. All right, we want to, it says, what did it say? Hold on. How long does it take for the rocket to return to the ground? Well, you can tell me from here. At 0 is when it takes off in the air. When does it hit the ground? At what? How many seconds? It's where the y is 0, where the height is 0. So it's going to be at this point right here. So it's 6 seconds. Okay, now how high does it go? Now here's the problem. You can either so that's going to take a while. What'd you get?
144.
144?
Yeah.
Okay, so trying to think here. I want it to go higher, but I don't want it to go as wide. Let's see, how can I do that? What is heck this? Grid. All right, x-axis. Okay. Well, and I know, let me see here. I want to keep the x-axis from negative 10 to 10. All right, and then let's see. I'm going to change the y-axis from negative. I'll keep it at negative 10. Whoops, where did it go? And then what'd you say it hit? 144?
Yep.
So negative 10. I'm going to try and keep that. And then I'm going to go up to about 200. So I can change this. Okay. So this is another way to change it without just doing the zoom in and zoom out. So you get a better picture of what you need to see. So you might zoom in or zoom out to see how far you need it. Then kind of go from there. Now, how'd you find 144? Did you just do that? Or was there anything else you did? Thing?
I just scrolled.
Just scrolled there. Okay, so it looks like it's going to be 144 as you take a look here. And then that gives us that point right there. All right, so if we go to here, how long does it take? All right, sketch it on your paper And I just need a sketch in these key points. It hits at 0, 0. It hits at 6, 0. And it hits at, what is it, 344? That's your vertex. That's your vertex. So if it takes 3 seconds to go up, it's going to take another 3 seconds to go down for that one. So how long does it take for the rocket to return to the ground? 6 seconds to return to the ground. And what is the rocket's maximum height? Maximum height equals 144 feet. Okay, 144 feet. So you might have to mess around with the, what we call the scale, so that you can see it a little bit better for that. And then let's see what else we got there. Okay, oh, we got the jumping frog. I don't think the jumping frog is going to get up to 144 feet. So go ahead and type in your equation for there. Let's see here. Okay, if you hit, I hit that home button, that'll basically clear your, if you change anything on the X and Y axis. Okay, over there on the right. Just hit that home button. Yep, it takes you right back to like 0. Hit that.
How do we use T?
There you go. Yeah, just use X. Just use X. All right, hit that home button. Where you were originally. Yeah, you're good. And you might get away with just zooming in and zooming out, okay? And okay, so what do we get here? Negative, is it negative 16x squared plus 12x? Is that right? All right, so I need to go back here. 12. And I think this is what you got. I am going to zoom in just a little bit. Now, mine's highlighted the maximum point.
Yeah.
2.25. Usually they'll highlight the key points. So don't just say 2 feet, because that would be incorrect. So it's going to be 2.25. And then, all right, what about right here? Where does that hit at? That's at 0.750. Okay, that's at 0.750. Let me see if I can use some of my fancy tools here. What do I got here? Where's my camera at? Let's send it there. Oh, hold on here. There it is. See, I cheated. I just copied it and pasted it. About how long is the frog in the air? What would you tell me? 0.75 seconds. So 0.75 seconds. 0.75 seconds in the air. And then what's the maximum height of our frog? 2.25 feet.
Yeah.
So max height equals 2.25 feet. All right, for that one. Now this one was a little bit confusing to me, so I'm gonna see if we can work it out here. You got to put in a table. Go ahead and clear that out. Go to the plus sign, hit the plus sign, and go to number 3 and hit table. Okay, go to number 3 and hit table. And enter, if you think you can do it, enter the values for the table, like the -110, -127. And I will do it here in a second, but if you think you're good, go ahead. It will plot those points. Okay, 2 seconds. Now, what is it? what does the question say? What does the question say? It says, use a table to determine the solutions of the related quadratic equation. It's telling us that there's a parabola that goes through those points. So if I hit table, under x1, I want it to be -1. Okay. Under y1, I want it to be 1. Okay. And under the next one, it's going to be 0. And then here it's going to be -1. And then the third one is going to be 2. And then 7. And so I'm going to just expand it. Whoops. So where's 2, 7 at? Let me see here. Okay, so I can see all 3 points. All right, now here's what you got to do to find the equation that goes through there. This is usually the form y = ax squared plus bx plus c. If we type that in there and under number 2, it will match those points. But we got to do a couple of things a little bit different. Since everything's under y1, see where this says y1 and x1? I'm going to have to put a y sub 1. And I got to put it's called a tilde because it means approximate. I'll show you where that's at, I think. Let's see if I can find it. And then a x sub 1 squared plus b x sub 1 plus c. I'm even curious to see if this will work for that one. All right, so let me see. I'm going to go here. I'm going to hit y. And then how do I do the sub 1? Y. What's that? 1. Oh, nice. And now the tilde. Where is that? Because it's like, it means almost. Let's see if it's on my keyboard. Where would it be? Let me go check with Mrs. Lavin real quick. See if I can find it.
Just one from your classes.
It's next to the 1, but you got to hit shift. You got to hit shift. So shift, and then the next there, and then we hit a x sub 1 squared, which would be here, plus b sub 1 x plus c. And it didn't work. No, it shouldn't be b sub 1. It's bx sub 1.
Get it right.
Oh, there we go.
That's what I told him. I said, if this like vaguely rings a bell, that's great. I'll probably remind you of this beforehand.
Yeah, we'll try to remind you of this because that's a lot of steps there. All right, that's it. I just wanted to show you this. Don't worry about that homework assignment that's listed under Canvas. You can press the hit, attaboy. You now know how you can do it. So you get the Desmos calculator, and then you can do it from there. All right, keep those notes. Enjoy your week off. Hopefully you get some rest and relaxation.
Yeah.
On the fridge. Yeah. You can keep the quizzes. I got half of them over there.
Oh, you're gonna split. That works out nice. You got the room right there, not me and you.
It did work out nice.
Was that by plan or did that just happen?
It's just happened the last 2 years we've had with Corey.
Yo.
My
I'm great. How are you?
inclusion class. This has worked out.
Alright, so on the work, if it's going, I got 5 seconds, if it's going, that's going up 5 seconds, and we're back down, right?
I think it goes up 2.5 and comes back down.
Alright.